Hey guys, welcome back to Rocket Gyan, my fellow space tubers. Okay, so for today we have a SpaceX mission, but this mission is a special one because today NASA is a customer as well as ESA is a customer. Means a satellite is being launched by Falcon 9, which is basically made and manufactured by NASA and ESA. More of it will be there in a second, but just an introduction of SpaceX company here. If you just don't know, SpaceX is a company led by Elon Musk, and it has revolutionized the space sector. And revolutionary rocket is on the way. This Starship, as you can see, it is a heavy lift launch vehicle around 150 plus tons into low Earth orbit is its capability, and the launch cost will be somewhere around $1 million per launch. That's the cost effectiveness of this vehicle. So now we can have a look at the Falcon 9 rocket itself. And here we have go the Falcon 9 rocket. It is basically a first orbital class rocket for reflight, and it has 97 launches, 58 landings, and 41 reflown rockets. So payload to low earth in expendable configuration is around 22.8 tons, which is basically when it does not reuse its stage. Okay, and then for anything else, yeah, this is the first stage. The first stage has this 9 Merlin engines stacked in octaweb configuration. uh, the 9 Merlin engine basically itself has its advantage of being used at basically you say very um, effective way, in the sense when any one of the engines also fails, then also the mission continues without any glitch and other thing, because then other nine others engine, basically other engine, adjust and gimbals itself so as to follow the same trajectory and burn for a little bit longer. That's the you can say specialty of this rocket, because all these engines are isolated from each other. So if any engine fail also, then also it does not affect other engines. That's the thing about it. The 9 engine, 7607 kilonewtons. And then we have the landing legs. So today we will be having a landing at the landing pad basically only. So today the launch profile is a different one. We don't be having any landing on the drone ship, but on the landing zone back to the launch site. So it will be a pretty interesting mission to watch at. um, then we have the second stage. The second stage engine is basically the Merlin engine only, but a vacuum optimized one with a bigger nozzle. That must I say. And we have then interstage, which houses the second stage with the grid fins in it. Then we have the payload. So today payload we have the Sentinel-6 satellite. I'll talk about that in a second, but now we can have something other. This is the Merlin engine. So this is a Merlin engine, as you can see, runs on a gas generator power cycle, as well as it runs on RP1 and LOX as its fuel. As you can see, it's a beautiful engine, and it produces around 845 kilonewtons of thrust by a single engine. Then this is a vacuum engine. You can see there is no pre-burner exhaust, but the pre-burner exhaust is being put directly back into the combustion chamber by this pipeline, which goes from here, and it has 981 kilonewtons of thrust. And yeah, this engine bell is very large, because to basically optimize the atmospheric condition. That's what it is. Okay. Mm. We have this. Now we can have a look at the mission profile itself. Here we go. So this is the mission profile. Sentinel-6 Michael Freilich Mission is this, and this is the mission profile. So we will be having a launch. Obviously the launch is from the Vandenberg Air Force Station, so any launch from there means we will be seeing a boost back burn and all those things, and a landing at the landing pad. So let me just quickly explain all this mission profile. So we will be having a launch here, then we will be having a ascent, obviously. Then here we will be having a stage separation, MECO, followed by stage separation, and then this the second engine start one. But then the interesting thing happens. So when the first stage is separated, then it quickly, without wasting any time, it rotates in a you can say not exactly retrograde, but it rotates in a manner so that it cancels out all its horizontal velocity. And when it cancel out all its horizontal velocity by turning out its engine, then we call it a boost back burn. So what it does is, in the boost back burn, basically it cancels out all the horizontal velocity going forward, and then it turns back that horizontal velocity to the landing zone. Okay, so when so for instance, when the you can see from here only that the if we don't do anything, the first stage will go and go like this. But since it performs a boost back burn, so what it does is, rather than going this way, it rotates its engine in this way. So the engine fires in this way, and then the rocket flies this and then comes back to the launch pad. So it's a very layman term I have explained, but that's what it happens. The boost back burn happens, then the grid fins deploy, then we have the entry burn. So since you can see only that the vehicle is slowed down very much, because we have two burns in here, the boost back as well as entry burn. So hopefully we don't lose any video feed during its descent. And then we have the aerodynamic guidance and the landing zone for its vertical landing, and it will be a beautiful stream to watch. So please have a look around that. Yeah, that's the thing. So the mission will be around 53 minutes longer, as you can see here, and we will be having two engine start. First will be that only, the first CS1, then the CS2 will be around 10 seconds to make it into its desired orbit basically. Okay, so now we can have a look at the Sentinel-6 satellite, if I'm not wrong. um okay, I'll just talk about the Sentinel-6 satellite, that will be better. uh, So, as you know, this Sentinel-6 satellite is developed by NASA and ESA, okay? And this is a satellite which basically is used to survey the oceans and all those things. From the look of the satellite also, it looks very jellyfishy type. I don't know, but for me it looks like that only. And now let me just tell you about it. The Sentinel-6 satellite will continue basically the oceanographic work of Jason 3 satellite that was launched in 2016. Okay, and this Sentinel-6 is designed to help scientists study climate change and improve weather forecasting. That's the purpose of it. As well as Sentinel-6 will be able to measure the sea level of 90% of the world's ocean with the millimeter accuracy, and which is basically a world record for any satellite to do that with the millimeter accuracy, basically measuring the sea level. So whenever the sea level is rising, the climate change is a pretty good concern for us right now, and this satellite basically will study the climate and will you can say warn us for any catastrophe event also, and we can have a look at that. So it will also collect data on atmospheric temperature, humidity, and other instruments which it will be having will be the radar altimeter for high precision sea surface topography measurements, and GNSS radio occultation, I don't know what it says, but an instrument to measure atmospheric temperature, pressure, and a water vapor. Okay, so we will the full name of the satellite is Sentinel-6A Michael Freilich, which is a tribute to Michael Freilich, the former director of NASA's Earth Science Division, who passed away this year. So this is, you can say, basically a tribute mission also. Okay, and it has two satellites. The constellation is of two satellites, the Sentinel-6A, the Sentinel-6B, and the Sentinel-6B is scheduled to launch in 2025. And these two satellites will basically perform for a decade of operation, and you can say enrich us with its valuable data. That's the thing. So let me just see if we have the stream of the official launch, and we can see if I can get to that. Yeah, in just few minutes or so we will be having the stream, so let's hope everything is cool. And guys, let me just tell you one thing which I should and must tell you, that this Sentinel-6 satellite, you can say, is a thing which I am really looking forward to, because right now very less satellites are there. I mean to say, not less satellite, but very you can say not very technological advanced satellite to measure climate change or to study the climate and atmosphere, which is going to be a pretty good concern right now. And just a fact here, if we don't do anything till 2030, okay, we have the deadline till 2030. Basically, if we don't do anything for the climate and let it be go like this only, whatever is happening right now, then by 2030 it will enter into a state that will be irreversible. Okay, so what I mean by irreversible, that the climate itself will be changing that much that it itself will be harming itself. So yeah, kind of makes sense or not? What will happen? The trees will start burning, so forest fires will increase. So that increase in the forest fire will cause smoke, and that smoke will again change the climate, and this thing will continuously happen, will be happening in a loop, and everything will, you can say, come to an end. I should not say this, but yeah, and we don't want that. So let's hope we can have something to do, and this satellite will be helping us to know more about the climate change and everything. So yeah,
Sentinel-6 is going to allow us to continue that record, so that we can better predict what is the rate of change, what is it going to look like. The rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It really impacts the daily lives of people and their ability to plan for their future.
And that's why humanity has been monitoring global sea level from space with exquisite accuracy for more than 28 years.
A satellite dedicated to uncovering new knowledge about our rising seas.
Okay, I don't know whether I should be allowed to have this thing on, because the music will then have a copy strike on me. So let's just talk about a bit more now. And this is just an introduction to him, to the satellite and to the person who has just passed away. So that's what is happening right now. And okay, so guys, if you have any questions also, you can just ask me and I'll try to answer till whatever possibility I have. And so yeah, so as you can see here, this is a basically will be helping us to know better oceans, and basically preventing tsunamis and floods and all those things. And this is a space launch complex for which is pretty good, because today we will be seeing a mission which we all want to see, basically.
And in just about half an hour, this SpaceX rocket will launch the Sentinel-6 Michael Freilich satellite into space to continue the important work of monitoring changes in our oceans around the world. And so it seems fitting this satellite will begin its flight over top of the largest ocean in the world, the Pacific. Welcome everyone watching on NASA and SpaceX's platforms. Thank you for joining us here at Vandenberg Air Force Base on the coast of Central California. I'm your host, Daryl Nail, and with me is Marina Jurica with NASA's Jet Propulsion Laboratory. So good to have you here.
Oh, thank you so much, Daryl. I'm so honored and excited to be here. The launch pad right behind us, Sentinel-6 getting ready to launch and giving us another decade of sea level observations. The science return is so critical, and I'm so excited to be here.
Now, you're a meteorologist as well, so you know the value of the data that's going to be coming from this satellite once it gets into space and starts working. But now comes the hard part, which is launching it into space.
I know, and I'm feeling so excited to get this Sea Scout launched and into action. I'm so invested in the incredible data that's going to come from this satellite, the legacy that it follows and continues. And we all live on this Earth here together, so we need to make it a better place for everyone.
Well said. And right now, as far as the rocket's concerned, we are go for launch. We'll get an update from Launch Control in a minute. We'll take a look at the pad, though. The rocket looking beautiful out there on Space Launch Complex 4. Now, coming up in the show, we'll learn more about Michael Freilich and why this satellite was renamed after him before he passed away. We'll also talk live with his son and his daughter after the launch.
The satellite he's named for can do some incredible science. We'll show you how it detects sea level changes down to a single centimeter and how it helps forecasters make better predictions about the strength and the path of life-threatening storms like hurricanes.
And just before launch, we'll talk about the cool secondary mission of the landing of SpaceX's first stage booster right back here on land, just a few hundred feet away from the launch pad.
Then after the launch, join us for a live transatlantic conversation about climate with scientists from NASA and ESA, European Space Agency.
But first, let's introduce you to the team of commentators who will be calling the launch today. NASA's Joshua Santora and launch trajectory analyst Philip Hargrove. Gentlemen.
Terrell, Marina, it's a pleasure to be here. Just really an honor, like Marina said. I am Joshua Santora with NASA Communications, and joining me, Philip Hargrove from NASA's Launch Services Program, or LSP. Philip, it's a pleasure to have you with me.
It's a pleasure to be here. Thank you so much for having me.
Yeah, so we are super excited, feeling the energy even from the East Coast, where we are located currently. The launch team, due to COVID environments, we're split across the country right now, trying to very literally distance ourselves. But part of the Launch Services Programs, their services provided, is to keep everybody around the world that needs to be in the loop on what's going on actively in the loop, and that's true for us here today. We are actively listening in to everything happening behind the scenes in the entire countdown procedures. So Philip, how are things going in the countdown procedures?
Yeah, things are going really great. It's been a big week of preparation, and we're finally in the final stretch, just about 25 minutes or so until launch. It's been a smooth count so far this morning. The teams got on console about 3.5 hours ago, around 6 a.m. Pacific time. And about 15 minutes ago, the NASA chief engineer, Akash Vengani, polled his team. The NASA engineers, the NASA launch manager, Tim Dunn, polled his team to ensure that NASA is ready for launch. And just a few minutes ago, the SpaceX launch director, Eric Kraskowiak, polled his team to ensure that they were ready for fueling, which just began recently. So the range is good as well, which means that the path to space is safe for the rocket and safe for the public, and the Falcon 9 is also proceeding nominally towards launch.
Yeah, all good things. Obviously, lots of teams there involved, and we'll talk about that in just a minute, but want to preview for you the fact that we have an instantaneous launch window today, meaning that we have a single second to be able to fly. We have a backup opportunity available tomorrow if it's needed, but that launch time today is at 9:17:08 Pacific time. Again, a reminder, we're launching from Vandenberg Air Force Base, Space Launch Complex 4. They're on the West Coast, so for those of you here on the East Coast, that's 12:17:08 Eastern time. So lots more to come. Daryl, we would typically provide you an update on the weather as well, but since you're there experiencing the weather and alongside a professional meteorologist, we'll let you take that one.
Well, we appreciate that, Joshua. Indeed, we are. You know, she's a certified meteorologist, and the weather today when we got up, I mean, it was picture perfect, you know, from the window of the hotel, clear, beautiful sunshine. You can tell how gorgeous it is. Didn't have the fog, but you know, we do have these winds.
Oh, it's so unusual, Daryl. I've been to a dozen launches here at Vandenberg, and I've only seen one of them because there's always fog along the central coastline. But fog needs really calm conditions. And so in order for calm conditions to happen, you can't have wind. But we've got a lot of wind out there today, and that is why we have no fog. But that wind might create a problem. And so that's why we need to keep a close eye on those upper level winds for this rocket. Now, you can see behind me, we have a couple of high-level clouds out there. Those are just cirrus clouds. I like to call them horsetails, but they are not going to affect the rocket in any way. It's a beautiful day. It's a clear day, but it is a little breezy. Now, 50% of launch scrubs are due to weather, and about 30%, Daryl, are due to upper-level wind issues.
Yeah.
And so these winds occur basically between 20 to 40,000 feet, so pretty high up in the air. And the rocket, it's like hitting a brick wall. fall when they hit those upper level winds. And upper level winds also change direction with height. So it is not good for the rocket, but I'm sure meteorologists are on top of it this morning at the weather office, and they're going to make that decision right before launch. But taking a look right now at our radar, we can see that it is crystal clear out there, folks. So we have no precipitation to deal with. Like I said, these clouds are not going to be a big issue in any way, shape, or form, which is good. They're just nice, high-level cirrus clouds. And looking at our launch weather forecast for the day today, we are 80% go for probability of launch, and that 20% contingency is just for the potential of those winds. So it's looking beautiful. I'm so excited to be here, and I'm so excited to actually see it. Because like I said, I've been here a dozen times, Daryl, and every time we just see so much fog in the area. So this is pretty incredible.
And we're perfectly situated for it here on just the mouth of the Santa Ynez River, spilling into the Pacific Ocean. It is an incredible view. We are blessed indeed.
It is so beautiful. Now, there are teams on opposite ends of the world working on this mission. The satellite will be controlled from the European Space Agency's Operations Center in Darmstadt, Germany.
Yeah, and here at Vandenberg Air Force Base, SpaceX's launch team is working the countdown from their control room, while NASA's Launch Services Program, that you see right there, is at the Mission Directors Center just a few miles away. Now, shortly after Sentinel-6 Michael Freilich is launched, it will start gathering a lot of data about our oceans around the world.
And that data will be collected by high-tech instruments on board the satellite. NASA's research scientist, Ben Hamilton, explains how.
From an early age, I saw images of the Earth from above. And you just realize how much is going on in the ocean, the variability that's there, the changes that are occurring. It really became a passion of mine to understand what's happening in the ocean. So sea level rise is really interesting because the impacts are local, but it's a global problem. So I've done a lot of work looking at sea level rise in particular locations, but on much broader scales, and with the satellites, we have this global view. So here we can see the satellites orbiting the Earth and where they are right now. Having overlap between the different missions allows us to make a direct comparison. And it's really the information we gain from all of these satellites that tell us about sea level change and allow us to get an understanding of what's happening on an entire climate system. And that really long record that'll exceed 30 years with the Sentinel-6 satellite allows us to have a better understanding of how the Earth's climate is changing. So this is an animation of the Sentinel-6 spacecraft and how it collects information about the sea surface. You can see the radar pulse that's bounced off the surface of the ocean. It measures the time it takes for that pulse to get back, and from that we can pull out the measurement of sea surface height. It's not just scientific curiosity, it really impacts the daily lives of people and their ability to plan for their future. As I started to live in coastal areas and see flooding that was occurring, I got to see firsthand the effects of sea level rise and climate change. You start to realize the importance of understanding what sea level is doing now. We can use that understanding to know what sea level might be doing in the future.
And coming up after the launch, we'll talk live with scientist Josh Willis, who's actually going to perform a live science demonstration about our rising seas. It's going to be something you want to check out.
And he is so incredible. I'm so glad Josh is with us this morning. You may have noticed this satellite was named after Michael Freilich. He led NASA's Earth Science Division for more than a decade.
And he did an outstanding job. Freilich, though, lost his battle with cancer in August of this year. But as you are about to hear, leaders in the space and science community around the world explain why they all agreed to rename this satellite after Michael Freilich.
I was so excited to receive a letter by the European Space Agency and the European Commission proposing that Sentinel-6A should be Sentinel-6 Mike Freilich.
Having a satellite named after you is pretty remarkable. It's not something we do in Earth science very often.
It's not only ESA, it's Europe who wishes to honor Mike Freilich.
Mike Freilich has been instrumental in making Sentinel-6 a satellite that measures with very high precision sea level rise.
The Sentinel missions are something that Mike was very involved in.
And it really epitomizes the role that Mike has played over the years as championing partnerships, championing collaborative investigation of the Earth.
Names are reserved for the greats. You don't name after a satellite after somebody who just does their job.
It's the second mission ever named after a person who's alive. It's a huge honor, and I couldn't be more excited.
Through this, we want to pay tribute to a unique cooperation between the U.S. and Europe, and a unique personality, Mike Freilich.
Dr. Mike Freilich is a world-renowned ocean scientist who, after a successful career in academia, came to NASA and for a dozen years led all of Earth's science.
And he's really brought NASA back on the international stage.
The partnerships that we forge are beyond a business transaction. They are about friendship, and Mike did just that.
Working with our international partners, working with our interagency partners.
And Mike brought that community together in a way that was really unprecedented.
Mike Freilich's legacy is being able to build the coalitions that are necessary for us to get as much understanding of our planet as possible. There is not another person more deserving of this honor than Mike Freilich.
Michael Freilich touched so many people, personally and professionally, and you had a chance to listen to him one time.
I did. He spoke at an AMS conference, and he was just so moving. His passion for Earth science missions was just incredible, and it was an honor to be able to hear him speak. Now, the Sentinel-6 Michael Freilich satellite has a long journey ahead to get into space.
But before it starts orbiting the Earth, the satellite already traveled halfway around our planet just to get to the launch pad behind us. NASA's Blair Allen tracked its journey.
On September 24th, Sentinel-6 completed its flight from the Airbus facility near Munich, Germany to Vandenberg Air Force Base and was transported by truck to the SpaceX facility at Space Launch Complex 4. Upon arrival, it was unpacked in the safe confines of the clean room. A team of scientists, engineers, and technicians began the critical process of preparing the spacecraft for launch. Over the last few weeks, they have thoroughly tested and checked out all aspects of the spacecraft to ensure its readiness for flight. The next critical step, the integration of the spacecraft with the Falcon 9 launch vehicle. Sentinel-6 was carefully encapsulated inside the rocket. Yesterday, Sentinel-6 and the Falcon 9 rolled out of the SpaceX hangar, covering the last few hundred feet of its journey on Earth to reach the pad at Space Launch Complex 4. Once vertical, the rocket is ready for all final checkouts before launch.
Separately, NASA and the European Space Agency have studied the oceans for decades.
But now the two have joined together for Sentinel-6 Michael Freilich. Joining us now is ESA's Guido Livrini, the Copernicus Space Segment Program Manager. Guido, it's great to have you with us.
Thanks for having me.
Well, we just saw video of the rocket rolling out and going vertical on the pad. You can see it there right behind us. It's ready to go. How are you feeling?
It's a big emotion. This project started in ESA more than 10 years ago, so it's been a very long journey. There are many memories that stand out, but the most vivid one is a lecture by Michael Freilich. He was just a few months after his retirement, so he was no longer the NASA director for science division, but he was normal US citizens, and was invited to make a lecture by our director, Josef Aschbacher, in Milano. It was July 19, and he gave us a lecture on international cooperation. Like a gentle, caring father, it made us realize that we don't do enough cooperative mission in Europe on our side. And coming here, I've been thinking about his words quite a lot. And indeed, he was right. If you think of a mission like Sentinel-6 Michael Freilich, it's a mission about sea level rise, it's a mission about climate, it's a mission about safe navigation. There is no reason why a specific agency or a specific country should take action or should care more than anybody else in the world. Yeah. And so you realize that a mission like that cooperation is the best way to realize a mission like that. And actually, cooperation is the only appropriate way, the only correct way to realize a mission like that.
You're absolutely right. We're all in it together.
That's so true, Guido. And you're right. Michael was such an inspirational speaker, and this collaboration is so beautiful. Now, we have a question from social media for you. Astro Asal on Instagram asks, what is the purpose of choosing this name for this mission?
First of all, we should all be aware of the fact that naming a mission after a person and a living person at the time is a unique event. We don't have any other example of this kind. It was an honor, but we are honored to work for a mission that carries this name. And the answer to the question is super simple. Without Michael Freilich, this mission would have not existed. We will not be standing here today.
Well
so
said.
True.
That's that's quite the honor. You're right. They do not just name any old satellite after any person. So it's quite an honor. Guido Lavrini, with Program Manager for the Copernicus program. Thank you so much for spending your time and sharing your thoughts with us.
Thanks for having me.
Thank you, Guido. Guido Lavrini with the Space Agency. Thank you.
We appreciate you being here. We want to take a brief moment now to honor our country with the singing of America the Beautiful.
And we're thrilled to bring you a virtual rendition sung by Musica, a group of youth ensembles and youth orchestras from California, Florida, and the Carolinas.
Oh, beautiful for spacious skies, for amber waves of grain, for purple mountain majesties above the fruited plain. America, America, God shed His grace on thee, and crown thy good with brotherhood from sea to shining sea. Oh, beautiful for patriotry that sees beyond the years, thine alabaster cities gleam under thy humid tears. America, God shed His grace on thee, and crown thy good with brotherhood from sea to shining sea.
Oh, that was so beautiful.
That
And
was
it's so
nice.
great to see all the kids playing and singing. Oh, that was just lovely.
And there's some applause from
I
our
know,
audience
from
gathered
our
here. And
audience here.
that's tough to get everybody in tune when you're not together.
All in separate locations, but so many orchestras and singers across the country are doing just that to keep the arts going.
It was beautiful.
All right. Well, we are now T-minus 10 minutes until launch, and this mission has a special treat for everyone watching. SpaceX is planning to land their booster just a stone's throw away from the launch pad.
Yeah, SpaceX has landed their first stage 65 times, but this is only the third time landing on land here in California. And joining us live to talk about it is SpaceX lead manufacturing engineer, Jessie Anderson. You might recognize her from such popular NASA SpaceX shows as Crew 1, Demo 2, Thanks for being here. It's great having you.
Thank you for having me. I am so excited. I don't think I can even contain it right now.
There, and you see the rocket there on the pad. Isn't that something?
It is a beautiful view, and I'm so excited to see it here in person.
Have you ever seen a launch and a landing in person?
So, not that I haven't tried. I tried to come last year, and, you know, Vandenberg is known for the impeccable fog. So when I came, all I saw was fog. So I heard it, but didn't actually get to see it with my eyes. So I'm really excited that it's a clear and beautiful day today, and hopefully we'll be able to see both launch and landing clearly.
No doubt. It's looking good so far.
Now, for those of people who are unfamiliar with the process, how exactly does the booster landing work?
Oh yeah, this is really cool. So after stage separation, second stage makes its way on its way to orbit, but first stage actually does a flip maneuver. So it continues to gain altitude and actually does kind of like a backflip. And then we have 3 burns that it does. So when it's doing that backflip, it does the boost back burn, which is 3 of the 9 Merlin 1 engines reigniting. And then following the boost back burn, it will do an entry burn to help slow it down as it enters back into the Earth's atmosphere. And then it comes back down and lands with just 1 single engine for the final landing burn.
It is the neatest thing to see in person, and it is loud. There's a big sonic boom.
Loud. Oh, yeah.
You have to even like warn the local residents that it's happening.
Oh yeah.
We want to actually share a special question with you right now. There is a young man, an 8-year-old named Parv. He contacted NASA and shared this picture with it. We want to put it up on the screen. He made a rangoli. This is a traditional decoration for Diwali made of sand, rice powder, and/or flower petals in the shape of a rocket. You see it there? There's
It's
Parv.
so beautiful.
He's got a little
He's so
SpaceX shirt on. You
excited.
see that? So they're here for the launch. They're watching. And his question to you, Jessica, is how do NASA and SpaceX achieve the pinpoint accuracy they need to launch?
Oh man, a lot of hard work to sum it up. But there's a number of things, you know, we have to calculate, you know, the orbital mechanics for how to get the satellite into space, but there's tons of sensors and guidance navigation control system on the vehicle. The vehicle is completely autonomous. So as you know, the vehicle is moving so fast, human reaction is not quick enough to guide it. So we actually have it autonomously programmed to make sure that it does everything that we need it to do.
It's amazing, and you guys have gotten so good at it lately. So we're looking forward to that part of it. Jessica Anderson from SpaceX, thanks you so much. You're going to stick around because for the landing, we're going to have you back out, and we're going to enjoy it together.
Yes, I cannot wait. I'm so excited.
All right, fantastic. Thank you, Jessica.
And now we're about T-minus 7 minutes until liftoff of Sentinel-6 Michael Freilich on a SpaceX Falcon 9 rocket.
That's right. The moment is upon us. We're going to hand it over to Joshua Santora and Philip Hargrove.
So guys, it's T-minus 6 minutes and I'm really excited. What about you? And since it's a clear sky and everything is looking cool, we can hope to have some very good views of launch and landing, and I'm really looking forward to that.
Absolutely right. So
enjoy the launch.
International partners from the European Space Agency, or ESA, and the NASA Jet Propulsion Lab, or JPL, who have science instruments on board the spacecraft that was developed by ESA. SpaceX obviously manufactured and produced the Falcon 9 rocket, and the NASA Launch Services Program, or LSP team, has been working closely with them for the past couple of years to prepare for today. And the United States Space Force Range is responsible for public safety today.
Yes, grateful for everybody's participation. Lots of good comments made this week during briefings and reviews about just the incredible partnership and collaboration here. So I want to tell you about what's coming up through the rest of the count as we proceed towards liftoff here in just 5 minutes now. We should hear a call for RP1 full in just a second, and then we'll be looking for the strong back retract to take place in just a few seconds.
Propellant tanks are pressurizing for strong back retract.
Perfect. So what that's going to look like on your screen is up near the top of that rocket where the fairing is, just beneath the bottom edge of that fairing. You can see that on screen there very well. There's a clamp that's wrapped around the second stage of the Falcon. That clamp will expand, and then that tower, the strong back or transporter erector, will tilt back just a couple degrees in preparation for the final minutes of countdown. It will still be connected.
Retract has started.
There's that call. The retract has started. That strong back provides power, fluids, and communication for the rocket up until the time of liftoff, when it will tilt back even further away from the rocket. So keep your eyes on that. But Philip, wanted to have you tell us about the path for today's flight. The folks along the southern coast of California might get a treat if they're outside looking up to the sky.
Right, I'm definitely happy for the people out there in Southern California because, you know, we get a million launches out here, but, you know, if they can finally see some, especially at JPL, because it's, you know, they're invested in this launch. So Vandenberg is really convenient for these high inclination launches. So Sentinel-6 Michael Freilich has a 66-degree inclination, which means that it's perfect for the Falcon 9 to launch south-southeast, and it's really going to kind of ride along the coast of Central and South America on its way up to that 1,300-kilometer altitude.
Yeah, very good. We just heard there Tim Dunn coming on the nets and giving his official go. So NASA is go for flight here. The last few minutes here, we're going to hear a number of calls with closing out liquid oxygen or LOX, and then we'll kind of tick down here to the final minutes where we'll hear we're commanded for final pre-launch. We'll have the automated flight termination system will be configured for launch. We'll get a final go from the launch director at around 45 seconds to go on the way to 0 there, right on time for this instantaneous window at 12:17:08 Eastern Time. That's 9:17:08 there on the ground. So Philip, really fast here as we're waiting for the liftoff. Tell us about the rocket here. You kind of told us about the flight path, but what is this rocket capable?
Wow, so as you can see here guys, this strong bed retract has actually retracted a lot this time. So yeah, I mean, the weight of this rocket means I don't know how do they manage to support the weight of the rockets. Obviously that all the weight of the rocket is not being just held by those engines, because those engines will definitely break. Must be some hold down clamp or something like that. So but this retract is so much, I think normally it is like 2 degrees or so, but for this we can see that piping for the umbilical, I should say the umbilical for the fairing conditioning is also like stretching, so it's looking cool, I mean say.
About 2.5 strong retract has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
And guys, just don't expect this stream to be a SpaceX classic one, because this is being broadcasted by NASA, and NASA's is a bit different. NASA stream is a bit different, and I don't think so we will be even having some overlays or so, but if it has, then it's cool only. So we are now T-1 minutes 19 seconds to the launch, and the weather is looking cool, the vehicle is looking cool, and we are go for launch. And let's hope this beauty, this bird flies into the skies to the space.
Falcon 9 is in startup.
Launch director is go for launch and landing.
Yes, we are go for launch. Oh man, this is happening.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
And T-minus 15, 14, 13, 12, 11, 10,
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of Sentinel-6 Michael Freilich, continuing a legacy of ocean observation and international collaboration
carrying Sentinel-6 satellite. Wow, just see these views. And they have written the background noise which you are seeing, hearing basically, is of those people which are actually seeing this launch. Wow. Man, today actually the weather is so clear to witness everything, and the next event should be the MECO, and first the vehicle will pass through max Q, and then MECO and the stage separation, and then the flip maneuver. not the classical one, but a different one. So we can see this thing actually flying, and wow, yes, Labrat.
Vehicle is supersonic.
Vehicle is supersonic, and now we will gradually see that plume expanding and expanding till we go to the space and then reaching.
Vehicle is experiencing maximum aerodynamic pressure.
And right now it is max Q, which is happening.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines.
And now it is started expanding, means it has reached the upper atmosphere. Hopefully now in just few seconds from now we will have a MECO, which is main engine cutoff. Man, this stream without those overlays and everything is looking so faded away, but okay, from next time onwards I'll only try
Beautiful
to do something.
clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now.
I'll only do something for
Just a
sure.
reminder, coming
Okay,
up
so
here
we
very
have a
quickly, we're
MECO,
gonna get
guys.
booster, or first stage engine cutoff.
Stage separation confirmed.
Stage separation has been
Booster
confirmed.
separation is there visible on screen now. Beautiful shot.
And the second engine has been started.
There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Well,
Stage 1 boost back burn has started.
okay, so boost back burn has already started, and we can, we were just able to see that,
And that
and
second
then
engine looks like it has lit. You can start to see the engine bell there turning an
Both
orange.
vehicles are following nominal trajectories. Fairing separation confirmed.
fairing
And there
separation.
goes the fairing. That's exposed. That is Sentinel-6 Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
So cool. I really wanted to have that boost back burn view from the ground. Do we have that cam or not? I really doubt, because this is broadcast is handled by
And stage
NASA.
1 boost back burn shut down.
Boost back burn has been shut down.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second
Both
stage.
vehicles continue to follow nominal trajectories.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle.
Oh, here we go.
So we are
This is
over
the
there, a
first
great
stage.
shot from the
Oh,
first
wow.
stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing, like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that.
And we will.
That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase today. And then we will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Oh, wow. Is this?
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
what I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there?
Ow. Okay.
All right. We're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
Exactly. The rocket launches are so heart-touching and emotional event to see, actually. I really wanted to see that first stage. I really hope that SpaceX releases some footage.
Second stage,
because this
Merlin
one is
vacuum
not up to the
engine,
mark.
MVAC, as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
Go on, entry burn has started.
All right,
Okay.
so call for the entry burn there. I think Daryl and Marina are ready for us. They should
here
be
we
there with
go.
Jesse to talk us through the landing. How was launch?
Oh my goodness!
It's incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. Can you tell that we were excited? We were standing there.
We can
saw
see
it.
that
It was
launch
so clear
pad.
we could see the separation as it was going the entire time. Jesse, I mean,
wow.
Isn't that
awe-inspiring.
Wow.
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out, and that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its
Hopefully
way
it
back
lands
to land.
properly.
So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back burner. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we
And here we
keep track
go.
of, is the engine cutoff of stage
Landing burn has started.
stage 2, and we're going to call that out. Here it comes. There it is.
Wow. Oh my goodness.
Coming in at an angle and just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness, I might cry right now.
So incredible. Every time I see this, it's just
Slowing down so perfectly.
perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my goodness.
Oh, that was
This was at some other level.
For landing operators
Beautiful.
proceed into 11.100 on recovery 2.
I'm a little
the
teary-eyed right now.
echo,
Wow.
the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? So that sonic boom is recognizable wherever
and
you are.
reverberating through the valley
Oh, I
here.
know.
I felt that.
Well, what'd you think, Jesse?
Oh, I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them cheering and everything. They're just totally like, in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
So much for having me. This has been amazing. Thank you.
Absolutely. Thank you. All right, well, the coast phase is about 45 minutes away, and so we don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment, but we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. Going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
It's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to, so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Sentinel-6. Really would like to thank NASA and our friends in the US, also NOAA, for this contribution they have made. Incredible. They have been an excellent partner. They have been very reliable, and they really have delivered their part on time and in very significant terms. The launcher we have just seen, but also very important instruments like the micro radiometer and several other components. And this is a model cooperation I would really like with Thomas and his team in the US discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there's much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Josef. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Great.
Sorry, this is a little...
You're coming back to me, or?
Yeah, we are.
What would you like to ask me so I can gather my thoughts?
Okay.
What difference is Sentinel-6 making to revolutionizing ocean?
Oh, well. They're still on, and they don't know. Hashtag live stream fails.
I don't hear the video. I don't hear the video.
She's missing.
She doesn't have a feed.
Give me a cue.
Okay. Oh, okay. So that glitch basically, which you just saw, happened because of the sync between ESA and NASA. It really is very difficult to sync in that in the live format only, because syncing in just offline mode requires so much of practice, and this in live mode, I don't know how did they do. And see, oops, we actually had something, but we got some views as in what happens backstage or something like that. So again, we are okay. Now we don't have the
Altimeter was actually an experiment on board Skylab, which was 50 years ago now. I mean, the way that this technology has transformed over this last half a century is quite fantastic, isn't it, Thomas?
Oh, it's amazing. I mean, for me, when you just think about it, you know, you have this spacecraft up there at, you know, 1,300 kilometers, going at 8 kilometers per second, and you're locating it within a centimeter or so, exactly with all these, with the altimeter, but also the GPS receivers and the supporting instrumentation. For me, it's mind-boggling, you know, and of course, it's so important because it affects our lives in a direct fashion every day, even if we don't notice that.
What challenges do you think that we're going to come across in the future with working with this international partnership?
So look, I believe that for the first couple decades, the question really was, are the ocean levels rising? The question to that is absolutely yes. Now, the question that we're dealing with, and as an international community, is how are we handling these rising oceans, and how do we make sure we don't go to levels that we don't need to? And so for us, kind of the local impacts of those around the world, whether it's in Europe, whether it's in the United States, and everywhere else, are what's going to drive our research, and therefore the high resolution that this spacecraft provides us is absolutely critical. So that's the questions the international community has to come together to deal with these problems, because each one of those assets, you know, serves all of us.
Well, we have been hearing more and more about how oceanography has been revolutionized by satellite observation. So Nadia, maybe you can tell us a little bit more about why Sentinel-6 is making such a difference in that development.
Yes, Sentinel-6 is indeed building on a very rich heritage of JSON-class altimeters, and what we expect to see a new science coming out of Sentinel-6, that it would open up new frequencies and give us a fuller picture of what do we know about the oceans. And ocean altimetry, by now, it's a mainstream tool of modern physical oceanography. So if you're a modern oceanographer, at one point of your life, You clearly looked with this data, either you're studying tides or sea level, ocean circulation, or winds or hurricane prediction. You were exposed to this data, and we expect from Sentinel-6 to continue doing this discovery on a higher resolution and longer timescales.
Well, if Craig can hear us over in Europe, maybe I can come to you as well, Craig, and ask you your opinion on how this technology is really changing how we monitor the oceans.
And obviously the memes are incoming for that part.
Track precision, which is essential because the annual changes are just a few millimeters a year. It's really remarkable. But, you know, it can do a lot more. And recent work shows that the oceans are taking up much more carbon dioxide from the atmosphere through the ocean-atmosphere interface, where waves play an extremely important role. Now, the Sentinel-6 Michael Freilich radar altimeter provides us with excellent measurements of the significant wave height with a 300-meter footprint size along the satellite track. Really, this will help us to improve our understanding of carbon dioxide transfer into the ocean. But it's even more than that. Wave forecasting is part of the Copernicus Marine Services for serving maritime operations, which are essential for maritime safety. And these are managed through the European Maritime Safety Agency. So we'll have topography measurements and wave measurements to really provide something pretty superb.
Oh, well, thank you, Craig.
If you wish, it is up to you.
And that was Craig Donlan, who's the project scientist from ESA, which is the European Space Agency. So thank you so much to them. And the climate science conversation continues. If you would like to tune in, just use the Sentinel-6 hashtag on the European Space Agency or ESA's social media platforms.
This satellite was renamed after American oceanographer Michael Freilich, who led NASA's Earth Science Division for more than a decade. Freilich passed away in August, but 5 months prior, NASA held a satellite renaming ceremony for him at the agency's headquarters in Washington, D.C. Freilich accepted the honor, but he credited his success to the contributions of thousands of scientists, engineers, managers, and diplomats on both sides of the Atlantic.
It's been a privilege to work with you, to learn from you, and to be able to call you friends. The entire world is expecting great things from Sentinel-6, and I know that you will deliver. Go Sentinel-6.
Certainly, he would have been thrilled to see this launch today. Joining us now is Daniel Freilich and Sarah Freilich, Michael's children, son and daughter. Thank you so much for being here.
Thank you
so much for having us.
Very welcome. Wow. So, you know, you just saw this launch. Your father's name is on the satellite. What were your thoughts as you were watching that?
It was gorgeous. Like, I haven't seen something that beautiful before.
It's amazing.
It's my first time seeing a launch from out here, and to just see that was incredible. Like, it means so much to see and feel it. You know, like, I'd heard him talk about feeling it, and feeling that as it goes is just incredible.
Amazing.
And we all talk about him in the space community as just being such an inspiration. I had the honor of hearing him speak once as well. And you guys know the man outside of the work. So tell us a little bit about him.
So our dad was passionate, and like whatever he chose to do, he wanted to like be a big part of it, and like was in all of the communities. And I like to tell people I didn't have heartthrobs on my wall. I had ESA and satellite images as the posters. And so that was just who my dad was. He shared it with us, and you know, like he was always there.
And I think another thing is, you know, he cared about things at all levels. So not only did he care about an individual mission, but he cared about how it affected the entire world. And he did that with everyone he worked with. You know, he talked about the people that he worked with. He talked about all of the science that happened. When we were going through his papers, actually, we found that he still had the science papers written about the impact on the world. So even as he moved on, like, he just cared about every part of the process, the people, the science, and what it meant for humanity.
You guys were sharing a nice moment with me yesterday when you said that you have talked to the people who worked with him. They talked about you guys, and then he talked to them about you. And so just sharing, the mutual experiences, and said that he was just the real person, the real deal.
Yeah, and he would push everyone to be their best in order to make everything better.
And we don't want to forget about Rosie here. This would be his grandchild, right?
His first grandchild that he got to meet, so that was very special. Yeah.
Beautiful. She's rocking the Sentinel-6 shirt. Look at that.
She's got her eyebrow. Sarah, you're a science teacher, right? So what part of this kind of carries through to what you do today?
So I think we do a big unit on climate changing because for me, sea level rise and what we can do as individuals is so important, and what my father was saying. And so as much as I teach science, and I hope that each student can find something that excites them, whether or not it's physics, biology, rising sea levels. But I want to make sure that there's a space for everyone to find something that interests them.
And Michael Freilich had a red pen. Do you have a red pen?
He has a red pen.
Oh, Rosie does.
Yeah, so Rosie got a red pen.
On the tradition, Rosie. Yeah. Just mark it up.
And it's so important, like you said, for future generations to be inspired and make a difference. Yeah, thank you, guys.
That's what he wanted us to understand, that this was our planet and it needed to be better for everyone. And so he always said to us, it's not that there's climate change, but the climate is changing, to try to build unity around this topic and have everyone understand what impacts they can make and why it's important to all of us.
That's very well said. Daniel Freilich, Sarah Freilich, and Rosie.
Yes.
Rosie, we're so glad that you could be here for this moment.
Thank you
It's
so
just
much.
incredible, and thank you for sharing your father's legacy with us.
Thank you for having us.
Thank you so much for having us.
Michael Freilich believed strongly in the mission documenting sea level rise. Earth's oceans affect us all, from the air we breathe to how they impact our climate. Let's take a look at how Sentinel-6 Michael Freilich will help us continue to explore oceans from space.
Spend a few minutes on any beach and you'll realize just how much the ocean can transform the shoreline. We're here at NASA's Jet Propulsion Laboratory, and we're really excited about this new satellite. It will extend the record of sea level rise another decade past the 30 years we already have, and allow us to see how sea level is not only rising, but how it's accelerating. This has huge consequences for the planet because sea level rise is one of the most important consequences of human-caused global warming. Sea levels are rising at a faster and faster rate every decade. We need these measurements to help us predict how quickly flooding will increase across the planet. Sentinel-6 will also bring us higher resolution measurements of sea level, which is incredibly important near the coastline where currents are narrow and changes can be difficult to observe from space.
Currents in the ocean tilt the sea surface, making sea level high on one side and low on the other. Also, warm water stands taller than cold, so sea level measurements tell us about both ocean currents and ocean heat.
Ocean currents affect our daily lives because the ocean has a strong impact on climate. In the west, the Pacific Ocean strongly determines droughts and rainfall, and in the east, hurricane forecasting uses satellite altimetry to help predict how much hurricanes will intensify. Ocean conditions can change quickly, and forecasters need data in near real time to predict how currents and marine weather will change across the globe. We're excited about the technical capabilities of this new satellite and the prospect of another 10 years of sea level measurements.
Give a little intro.
And Josh Willis is here, more affectionately known as Climate Elvis, joined by NASA's Blair Allen for a live demonstration.
That's right, Marina. Josh is here. The king is in the building with some
Thank you.
Deep,
Thank you very much.
deep insight into the science of Sentinel-6. So let's start there. Before we get to the demonstration, tell us a little bit about the science behind this mission.
Well, Blair, first I got to say, that was amazing.
I know, right?
I just saw that the rocket went up and then it came back down.
Yeah.
And so did the boom. It lowered the boom on us.
It did lower the boom, even when you know
amazing.
it's coming.
Yeah.
It's still shocking.
Boom.
Yeah.
Sonic boom. It was cool. But
it dropped the mic on us.
it dropped the mic, as I know you were going to do at the end of this segment.
Well, let's hear it.
So Sentinel-6 is going to tell us about the sea level. It measures the height of the ocean from about 800 miles up, and it does this with an accuracy of just 1 inch. And yeah, right?
Yeah.
Pretty cool.
Yeah.
And so it does that everywhere in the world, once every 10 days. And from that, we can figure out global sea level rise, how much the oceans are rising because of human-caused climate change. So it's pretty neat.
Yeah, now one of our followers on Twitter, Ave, wants to know if they're twin satellites, why are they being launched 5 years apart?
Yeah, that's a great question. They're twins, but one's the younger twin. Okay. Significantly younger twin. So yes, so the idea is that we have to keep measuring sea level rise. Sea level rise is not going to stop anytime soon, and we have to keep our eye in the sky looking down on it. So we just launched the first one today. In 5 or 6 years, it'll start to age, and we'll launch the second one, and it will continue the record another full decade. Awesome. And that's a big deal because sea level rise is actually accelerating. So the rate of rise, in the 90s, it was about 2 millimeters per year. In the noughties, it was about 3 millimeters, the noughties, you know, the decade starting in 2000.
I know, but let's see the demonstration.
Yeah. Oh,
Go
okay,
ahead.
yeah,
Bring
sure.
us
So,
to it. Yeah.
okay, so, all right. What happens when you hold a flame to a balloon?
I'm going to say it pops.
That's right.
But I'm just a layman.
Well, this layman is right. Let's find out, right? Now, in order to do this, I have to put on my safety gear. So here we go.
There you go.
Now, we're gonna do this, all right?
Yeah.
And it's gonna pop, right? Here we go.
Okay.
All right, 1, 2. Wow. It was terrifying, wasn't it?
This guy is so
Frightening,
amazing.
right? Now, what happens when you do the same thing with a balloon filled with water?
It won't
I'm
pop.
assuming it pops as well, right?
Let's
It does
find out.
not, the
Here we go.
water evaporates.
Look at that.
Fascinating.
Look at that. It's right there. It's right there on the balloon.
It holds.
It's not popping.
Why not?
It's not popping because water is so good at absorbing heat that it actually takes the heat away from the balloon before the flame can melt it. And that's just like the oceans. The oceans absorb more than 90% of the heat from climate change. So if we think about global warming, it's really ocean warming, right?
Wow.
That's pretty cool, huh?
That is amazing.
I'm really glad it didn't pop. You know, I was afraid I was going to have to give up all faith in science and join the circus.
We don't want you to do that.
No.
Well, thanks so much, Josh.
Yeah, you betcha. It was.
Yes. All right. So
This is
science has
amazing.
also
Yeah.
left the building along with Josh.
Okay.
Back to you guys at the gravel pit.
I'm going to go join the circus now. Yeah.
Well, Blair and Josh, thank you so much. I guess he's a hunk of burning balloon or something. Well, anyway, we want to recap the launch now. Just about a little more than 25 minutes ago. We launched from right here at the Vandenberg Air Force Base, courtesy of the 30th Space Force Wing. There it is, the Falcon 9 rocket and Michael Freilich spacecraft on at around 9:17 this morning, Pacific time, 12:17 Eastern time. There you see liftoff. The Falcon 9 rocket soaring into a beautiful blue sky over the central coast of California. The launch was picture perfect. Look at the shot right down the center of the rocket as it left the coast here. The mission to launch the Sentinel-6 Michael Freilich satellite into space. And as it got up off the ground, the launch, it seemed the rocket was taking its time, nice and slow. It's a nice heavy satellite up there. But once it cleared the tower and got up into the upper parts of the atmosphere, boy, it started to race. Michael Freilich's family were on hand to watch the launch, and it was just an incredible sight to behold. A wonderful a time had by all. We had guests and friends and relatives of Michael Freilich out here to watch it. And then just a few seconds later, about 8.5 minutes to be exact, the booster came back down to a nice soft landing. Just several hundred feet away, there came the booster touching back down on the landing pad. SpaceX now able to reuse that booster. And now The spacecraft is in flight, and we are tracking its progress. Joshua Santora and Philip Hargrove are keeping an eye on the progress of the launch.
Oh, that was just...
It was something, wasn't it?
Inspirational.
It's incredible.
So beautiful. All right. Well, there are more than half dozen international partners on the Sentinel-6 mission.
Yeah, the European Commission paid to build the satellite earlier, but we spoke to Europe's ambassador to the United States, Stavros Lambrinidis, about its importance to Europe. Ambassador Lambrinidis, thank you so much for being with us.
Thank you for having me.
I want to ask you, first of all, how important is the data that comes off this satellite for the continent of Europe?
It's supremely important because as we are coming out of COVID and we're trying to rebuild our economy and the health of our people, we're doing so by protecting the climate and protecting the environment. Climate change is an existential threat for all of us, and we need all hands on deck to address that challenge. And, you know, today what we're seeing, what we saw, is an exemplary story of European and American friends working together for the greater good. For Sentinel-6, we pulled together our best engineers, our best scientists, our best resources. We mobilized the public and private sectors to produce the most advanced ocean monitoring data in history.
With that thought, I want to ask you on a personal level, what is the significance of this launch for you?
Well, I'll tell you, as the EU ambassador, I am proud. I am deeply hopeful for the future of a planet, and I am touched. I am proud because Sentinel-6 is at the center of the European Union's Earth observation program, which is called Copernicus. And I'm especially proud that we are making this decisive scientific move in partnership with our American friends.
Back to the partnership. Sentinel-6 Michael Freilich is actually NASA's first direct partnership with the European Commission. So take me back to the beginning. How did this all come about?
Well, it all came about from a remarkable success story of European cooperation, first of all. So Copernicus came from a cooperation between EU institutions and intergovernmental agencies such as the European Space Agency, the European Organization for the Exploitation of Meteorological Satellites, down to national space agencies and the industry. So this was first and foremost a European success story.
And now that satellite has been launched into space, and we look forward to getting all of that data for the better of the entire world, really. Ambassador Lambrinidis, thank you so much for joining us today.
Thank you. Thank you very much.
Meteorologists understand the critical importance of advance warnings of severe storms across our nation. One of the instruments aboard Sentinel-6, the Global Navigation Satellite System Radio Occultation, or GNSS-RO, will be the next tool for more accurate forecasting. Let's take a look.
Sentinel-6 Michael Freilich will provide important information in producing our daily weather forecast. So how does this work? The data from the GNSS-RO, that stands for Global Navigation Satellite System and Radio Occultation, a new instrument on board, is ingested into the weather models that can help us with our weather forecasting and our warnings to help protect the public.
This mission will use a special technique called radio occultation, which measures tiny changes in the radio signals broadcast by GPS and other navigation satellites. The GNSS-RO instrument essentially measures the time delay of the radio signals as it goes through different layers of the atmosphere. So this allows us to unravel the temperature and moisture content of the atmosphere layer by layer.
Most of the weather that we experience comes from our west over the ocean that lacks conventional observations like what we have over land. The GNSS-RO will help address these challenges by providing us very important temperature and moisture information over the ocean that will help our forecast here on the West Coast.
Studying the entire atmosphere, from the surface all the way up to the stratosphere, is important for us to improve our understanding of our weather and climate change.
We're very excited with the data that the GNSS-RO will provide for these weather models that will ultimately help improve our forecasts and warnings to help protect the public.
Eric Louliette is the NOAA, the National Oceanic Atmospheric Administration's program scientist for Sentinel-6. NOAA is one of the Sentinel-6 partners and will use the data from this satellite on a daily basis. Thank you so much for joining us, Eric.
Thank you. It's a really exciting day to see that beautiful launch.
Oh, it was so spectacular. How will Sentinel-6 help meteorologists at NOAA and across the nation? The GNSS-RO instrument will provide a temperature and humidity profile throughout the atmosphere, which is pretty awesome.
Yeah, indeed. We're very excited at NOAA to be using data from all of the instruments. We'll be using from the radar, measurements of winds and waves that will go right onto forecaster screens. We'll be using the sea levels to improve ocean current forecasting, which will help for navigation. We'll also be using those sea levels to measure heat content, which is really important for sustainable fisheries. But as you also say, we saw from that last video how we'll be using the GNSS-RO instrument to profile the atmosphere, measuring humidity and temperature in the layers. And that'll help us do all sorts of improvements to forecasts, including using the atmospheric measurements to monitor hurricanes from their formation all the way through their whole life and dissipation.
And Eric, we have seen great improvements in forecasting hurricane tracks over the years, especially with the launch of GOES East and West. But how will Sentinel-6 help with forecasting the intensity of these storms?
Yeah, one of the reasons that hurricanes can become intense is because they feed off the energy that's stored in the upper layer of the ocean. As you saw from Josh's demonstration with the balloons, the water in the upper layer can store a lot of heat. So what we can do with Sentinel-6 is by measuring sea level, we can measure how much the sea level has expanded. That's a proxy for how much heat there is stored there. So we can figure out how much heat and where it is and map it and send those maps to forecasters. This year alone, we've seen 10 tropical storms increase in intensity rapidly. So it's more important forever that we have than ever that we have Sentinel-6 there for the next decade to monitor and improve hurricane forecasts.
Yes, ocean heat content is so important. I always like to think about it as a car that needs gasoline. A hurricane needs that warm water to fuel that engine, that's for sure. Now, what impacts to society do sea level changes have, and how will Sentinel-6 help us better plan and prepare for the future, Eric?
Sure, for the last 30 years, we've been seeing sea levels rise using the satellites that are the predecessors to Sentinel-6. And one of the things we've learned is that sea level doesn't rise at the same rate everywhere. So it's vital that we use Sentinel-6 to map where the sea levels are rising. We've already started seeing flooding both in clear weather from places all the way from Hawaii, the Florida Keys, to Norfolk, Virginia. So we're going to need Sentinel-6 and working with our NASA partners to help make better models to figure out where we should expect increased flooding and storm surges as sea levels continue to rise.
Thank you so much, Eric, for joining us today.
Thank you.
Another fantastic tool on board is Sentinel-6 is the Advanced Microwave Radiometer for Climate, or the AMRC. And the person who led the testing and integration was JPL's Shannon Statham.
In order to be good custodians of our planet, we really need to understand how it's changing. How is it evolving? And here we are at High Bay 2. This is actually a clean room, and each component gets tested on its own, and then we assemble it together. So my team was responsible for assembling, testing, and delivering AMRC for the Sentinel-6 mission. And this is where we built it. AMRC is the Advanced Microwave Radiometer, one of a suite of instruments that work together on Sentinel-6 and then give us the very high resolution heights of the oceans. So we are in the antenna range at JPL, and this is where we tested AMRC. We need to know that what we send into space is going to survive. I've always had an affinity for arts, singing and dancing, and so one of the things I've been doing more recently is sewing. And my dress, I actually sewed You cannot do this job without being creative. Every mission is unique. We are answering those really interesting and hard questions that we all have about our universe and our planet.
Shannon Statham joins us live now on this exciting day. Boy, what a textbook launch. Welcome, Shannon.
Thank you so much for having me. Yeah.
Now, you work on the Advanced Microwave Radiometer for Climate instrument. Now, what is the exact role of the AMRC?
Yes, so AMRC works in conjunction with the Poseidon radar to get those very precise measurements of our sea level heights. And effectively, AMR is looking at water vapor in the atmosphere, so clouds and rain and snow. And that affects the radar measurements because it basically causes a delay in the signal returning back to the radar. So ocean heights might look a little closer or a little further away due to those effects. So AMRC, we take the data from AMRC and we're able to resolve those effects out of the data and then get those very precise measurements.
We're in the super science part of our show, by the way. You know, we're really hitting it hard. This is great. Want to ask you, you also do testing, right? Because this thing helps with accuracy, but you've got to test it to make sure that it will be accurate. How do you test for mission and launch environments?
Yes, so at JPL, we have a number of facilities that simulate launch and the extreme temperatures and vacuum of space. And so everything that we build is going to go through this test campaign where we certify it for launch and we certify it for its space environment, and not only ensure that it will survive, but that it will perform the way that we need it to throughout the mission.
And the AMRC instrument, Shannon, I know we've talked about this before, it is much more difficult and complex than its predecessors. And so you didn't really have a blueprint on this one. How is it different?
Yes, well, for every mission, we're going to, push that envelope, try to use the latest technologies, and AMRC is no exception. So we have two new components on AMRC compared to the predecessors, and that is a high-frequency component that enables us to get more precise measurements near coastal lines. In past missions, as we're over the oceans, we see really precise heights, but as we got to the coast, things were a little blurry. So now we're going to be able to get those better measurements near the beach, which people care a lot about because that's where they live and that's where they have businesses. And we also have an onboard calibration system, and that includes a rotating mirror, so of course just adding to that complexity. And that was because of some new science requirements on Sentinel-6 to get us even better data throughout the mission.
And folks in Florida certainly care about that because there are more There are more miles of populated coastline in my home state of Florida than in any other state. Got a question from social media for you.
Okay.
Hank reached us from Facebook, and he wants to know how accurate is the satellite? What is the smallest area of ocean it can measure the altitude of? And might it have any applications for detecting seismic activity?
Oh, a very interesting question. Yes, so for a single measurement, we can get down to 3-centimeter accuracy. But as we continue to take those measurements, we get global coverage over a 10-day period, and then we continue. We continue to get the map of the full of our full planet and all the oceans. And so over the span of a year, we get down to millimeter resolution. So that's an order of magnitude better than a single measurement, and how we're able to get those global averages of 3-millimeter height increase per year, which is really, you know, if you think about over the span of a decade, that's a centimeter, and over the span of a millennia, or a century, excuse me, that's going to be 10 centimeters. So we're definitely seeing the rise, and definitely seeing the sea level impacts.
Real quickly, the seismic activity?
Yes, the seismic activity. So although Sentinel-6 is not going to be trying to detect seismic activity or tsunamis, which often come as a result of that over the oceans, but we have been able to detect them in the past. Previous missions have been able to, but really what we're going to see is any changes in the sea levels as a result of that seismic activity and any tsunamis.
Very helpful. That's all data that is very important to our world. Shannon Statham, thank you so much for joining us from JPL.
Thank you so much for having me.
Yep.
Thank you, Shannon.
All right, all of these highly accurate Earth-observing instruments were installed onto one satellite that will orbit our Earth for about 5 years.
NASA's Blair Allen asked Sentinel-6 project manager Parag Vazay to show us how they did it.
Joining us now is Parag Vazay. He's the NASA project manager for Sentinel-6, and he's going to talk about a few particulars on the spacecraft. But Parag, before you do, I was wondering if you wouldn't mind talking a little bit about the science behind this, altimetry.
Yeah, altimetry is a science. It's basically using microwave instruments, using them from space so that we can cover the vast oceans that we have across the whole world. And the whole objective with altimetry and ocean altimetry is to be able to measure those oceans across the world, measure them very precisely. And doing that with a satellite from space allows us to do it completely and most accurately that we can all across the whole world.
So let's look at the instruments. Can you tell me about the primary instrument for Sentinel-6?
Yeah, the primary instrument is the Poseidon radar altimeter. It's built on a simple concept, which is like any other radar, where basically we are producing a radio signal from the instrument. It's being transmitted down to the Earth from space, and we're waiting to actually get the reflected signal off the ocean surface back up to the antenna and receiving that signal. We want to understand how long it took for that signal to get it back here, and then with that, we're able to understand what and measure what the height of the ocean is.
And there's another important instrument on board, the Amrc. Can you talk about that and its purpose?
Yes, you're right. This is the Advanced Microwave Radiometer, a very important instrument for doing this measurement, because the Poseidon altimeter measures the height, but it really matters how well that is measured as that signal passes through the atmosphere. And we need the microwave radiometer to be able to measure differences in that signal as it passes through the atmosphere. This instrument provides us that correction so that together we're able to make a very precise height measurement of the ocean surface.
What are some other important features or instruments that are flying on Sentinel-6?
Yeah, we're lucky because on Sentinel-6 we do have an additional instrument which is called the radio occultation receiver that's right here with the antennas that you see here. It's a totally different concept, but similar in some sense, where we're actually trying to measure how radio signals bend through the Earth's atmosphere that we get actually from other satellites. So we use signals from the GPS constellation, which is transmitting a signal, and these antennas will receive it through the atmosphere, help us understand what the atmosphere is like in terms of temperature and humidity.
Well, we're very excited about the spacecraft and obviously the data we're going to get with Sentinel-6. Thanks so much, Parag, for being on the show.
Thanks, Blair. As we have mentioned, Sentinel-6 is a true international collaboration among several agencies around the world. It was built upon a legacy of Earth observation missions. Let's break down how this partnership came together. The Sentinel-6 Michael Freilich satellite is the culmination of decades of international research and development of satellite altimetry designed to measure sea surface height. In the early 90s, NASA and the French Space Agency launched Topex Poseidon, the first in a series of next-generation altimetry missions that includes the Jason satellites. Meanwhile, the European Space Agency created their own successful Earth observation program called Copernicus, which includes the Sentinel series. In an effort to maximize the technology and resources on both sides of the pond, NASA, NOAA, ESA, EUMETSAT, and the European Commission all joined forces to create this satellite, Sentinel-6 Michael Freilich. The name itself is emblematic of a mission greater than the sum of all its parts. The first part of the name, Sentinel-6, is derived from ESA's series of Sentinel satellites, and the Michael Freilich part of the name honors Dr. Michael Freilich, the former director of NASA's Earth Science Division and a tireless advocate for advancing measurements of the ocean in an effort to better understand the planet we all live on.
As you just saw, EUMETSAT, or European Organization for the Exploitation of Meteorological Satellites, has been operating the Sentinel series of satellites from the very beginning. Earlier, I spoke with the agency's Director General. Director General, thank you so much for joining us today.
It's a pleasure.
So, Elon, EUMETSAT has been involved in these high-precision altimetry missions for a long time. Can you tell us a little bit more about EUMETSAT's role over the years and how that's developed?
Yes, we became involved with JASON-2, which was launched in 2006, and then we continued with JASON-3. And this was in cooperation with CNES, NASA, and NOAA, and it's reflected the interest of the operational agency to contribute to these missions. But we had a minor role technically. We were just processing real-time data. And with Sentinel-6, we have a much more important role because we develop most of the ground segment, and we will perform flight operations and deliver the data.
So when will EUMETSAT take control of the spacecraft, and how long will you be operating it?
So we will take control of flight operations 3 days after the launch, after the what we call the early operations phase, which will be performed by ESA, and we will operate the spacecraft and the system all along its lifetime.
Very good. And since oceanography is a field that's dear to your heart, I know, can you explain to us what the difference this new satellite will make in our understanding of our oceans?
Yeah. First of all, this satellite will preserve the integrity of a unique record of mean sea level started with SpaceX Poseidon in 1992. But it will also improve the accuracy further. So we were 3.5 centimeter with SpaceX, we were 2 centimeter with JASON, we will be 1 centimeter for this spacecraft, and we will also have better spatial resolution along the track, 300 meters instead of 7 kilometers. So it's a major improvement, will come closer to the coast, and it will be very important not only for climate monitoring, but for forecasting heat waves in Europe, for instance, cyclones, and also whether the next summer will be unusually hot. So that's what we expect from this mission.
And we've talked a lot about cooperation, Director General. So how important is that to EUMETSAT in this endeavor?
So to make it short, one of the aspects of cooperation is science. But I would like to close saying that at this meeting, the ambassador of the United States in Japan, Caroline Kennedy, was given the floor, and she said, "I am a fan of Michael Freilich." And so tonight, the US and Europe are fans of Michael Freilich.
Well, thank you for sharing those thoughts on Michael Freilich, and congratulations on the successful launch of Sentinel-6 Michael Freilich into space. Director General Alain Ratier, thank you so much for joining us.
You're welcome.
It's time to check in on the progress of the launch operations.
That's right. Joshua and Philip, they are about to light that engine for the second stage, but it's not expected to last very long, right?
Yeah, that's correct. I'm just checking my comm loops here, make sure we're hearing everything. We're expecting to hear that call for the second stage, second burn, any second now. So we're kind of in a holding pattern here, just kind of cycling back on the day. We had successful on-time liftoff at 9:17:08 Pacific time. There you see on screen, that's a track.
Nominal payload insertion orbit.
That's a great call. I believe, Philip, help me. I believe that's a call for, like, we've completed the second stage burn, a nominal insertion orbit. That's where we wanted to get to, right?
Exactly. Yes, the first stage did most of the work of getting out of that gravity well to get away from Earth into orbit, and then that second stage, second burn, was really just tweaking to get into that final circular orbit.
Yeah, fantastic. And we're seeing now some great shots from that second stage, and we saw the spacecraft there a second ago. So that track that the rocket has flown, it's tough to see because this is simulating, this image on screen is simulating being in the shadowy part of the Earth right now. So if you look really closely, you can see we're kind of approaching, if not in the Indian Ocean now, we're to the east of Africa. The track, as Philip mentioned earlier, that 66-degree inclination kind of put us around the tip of South America and then around the tip of Africa without actually dipping down to Antarctica. So kind of a fun track to take. We're expecting to have signal acquisition of the spacecraft over around Alaska. So lots to come ahead. But Philip, I want to ask you about your work, because this is kind of the bread and butter of your job as a flight analyst. You definitely pride yourself on getting to this point and beyond. So tell us about what you do.
Right. I mean, be careful with that question because we've been talking orbits all day. So, don't get me started on it. But when you talk about trajectories in the launch sense, there's really two pieces. There's what happens when you are in orbit, when you're already in space. And then there's the unique question of how do you get from the launch pad into orbit. So at LSP, at the Launch Services Program, we really speak both languages. So we want to be able to take the work that the spacecraft team does to determine what all of their needs are in terms of where they need to be and when they need to be there, and we help translate that efficiently to the launch vehicle, who has their own process of designing the actual trajectory to get from the launch pad into orbit. So we support that process however we can.
Yeah, and that's, as you kind of alluded there, that's really the bread and butter of the broader LSP picture. Working with a spacecraft customer to acquire the vehicle. We heard Tim Dunn speak about that yesterday, just the acquisition of the vehicle and the service to get into orbit as you need to be. So what's kind of that picture like for LSP? What's the process at large?
Right, so we really just want to support those spacecraft and do whatever needs to be done to make sure that they are going to be placed into the specific orbit safely. So there's a lot of things that LSP does to just keep a grasp on the evolving launch vehicle markets. Being able to know exactly what the spacecraft is or what the launch vehicle is going to do before it's actually purchased, so we can advise them so they can do their planning years in advance before they're even purchasing their vehicle. So we really just want to sort of be that interface for NASA.
Yeah, and I want to check in for a second to say we just heard a call of acquisition for Diego Garcia. That's not the spacecraft acquisition. That's a stage 2 acquisition. So we'll be looking for this spacecraft acquisition over Alaska as we get to the Alaska general geography. And we're hoping to, ahead in our show, bring you the spacecraft separation video live or close to live. It'll be a few seconds delayed. It takes a few seconds to get that signal back from the other side of the Earth where we already are. I do want to go ahead and bring in now another flight analyst, Callie Burke, who's also with Launch Services Program. Callie, thanks for joining us today.
Yeah, I'm here in my own little booth in the Mission Director Center.
Yeah, I appreciate you. You're kind of isolated there in our booth over there. Glad to have you. And I know you wanted to talk a little bit about today about kind of the choosing of the orbit we're in. Obviously, we had a good call out for nominal insertion burn. So where are we and why did we choose this specific orbit?
So as a Launch Services Program, we go where the spacecraft ask us. And so we're going to, if this was the equator at 0 degrees, we're going to a 66-degree inclination. So it's a high inclination orbit. And so it's joining the same one that Jason 3 is in decades of continuous data. And so that going up that high means we go up, as high as Alaska and Sweden, but then sweep down below South America. And so it's a nearly circular orbit. And so it's around, around the Earth, it's about 800 miles above the Earth, which is about 1,300 kilometers.
And why such a long coast phase? I know that for those that are familiar with rocketry, they kind of are accustomed to science missions and robotic explorers having a coast phase that can be fairly lengthy. But why this 45-minute coast before the second burn?
So with the rocket, we bring all the gas with us. There's not gas stations in the way. So we want to try and use as little as possible. And so just the way that it works is that, we start
Callie, I want to jump in there for
we
a
fly
second.
up in
Just
the
to
early
say
parts to a
we're
park.
looking at the spacecraft separation right now. I want to let you finish, but we're getting that live, and I wanted to call that out for you. So there goes Sentinel-6. That is a beautiful sight. Watching it drift off there. Again, we are kind of shaded by the Earth, so we're not in direct sunlight at this time. So that's why it's as dark as it is. If the sun were on this side of the Earth, we'd see a little bit more of that, but that's going to kind of just drift off, and that's completely normal and expected. So, Callie, I do want to let you finish. Sorry for jumping in there.
No, yeah, that's the part, exciting part when the rocket's done its job. So what we did was we got to a park orbit coast with the boost and the first burn. And so with that, we still had a perigee, so the point we're closest to the Earth, just above 160 miles. And so we're near that. And then we coast and just let physics do its job, where we go out to the furthest part, 800 miles. And then at that point, we just have to do a short burn, just every 10 seconds. A little bit more, and then we circularize the orbit. So we are just using a little bit of fuel at that point. So
awesome. Hey, last question for you really quickly. I wanted to ask about the question of how far would we be behind Jason 3? Because obviously we're trying to be in that exact same orbit like you mentioned, but how far away are we?
So what we're doing, so we have our launch time so that we're in the same orbit plane as Jason 3. That's why we had just that 1 second to launch. And then we're going to be just minutes behind. And they're zooming around at 3.5 miles per second. And so if they get, if Sentinel-3 gets as close as just 30 seconds behind Jason 3, that's still 135 miles behind it in the orbit.
Yeah, I think I just heard you say 3.5, but I know we talked that numbers that we deal with a lot of numbers, and I wanted to make sure was it 3.5 or 4.5?
It is 4.5.
Okay,
you are
yeah,
correct.
No worries. Again, we deal with lots of numbers. Callie, I appreciate you being here with us. Thanks so much, and appreciate your hard work for LSP and getting our spacecraft customers where they need to be.
Yeah, go Sentinel-6 Michael Freilich.
Yes, awesome. Thank you so much. Yeah, that speed of 4.5 meters per second. Or miles per second, thank you. It actually means that we're traveling at a speed that would put you from ESA's headquarters in Paris, France, to the launch site at Vandenberg in about 20 minutes. So pretty speedy there. There are still a few milestones ahead. We hope you'll stay with us. We're going to send it back over to Daryl, but just preview for you quickly. Solar array deploy is ahead, and then that signal acquisition we mentioned. Daryl, back to you.
All right, thank you, Joshua and Philip, and I want to fly that fast.
Yes, woo, get you from point A to point B in a lickety-slip.
Now, while we await the deployment, we have a special guest who is responsible for NASA's Physical Oceanography program.
She's also NASA's program scientist for this mission. Nadia Vinogradova-Schiffer joins us live now. Nadia, what a textbook launch. That was so beautiful.
Absolutely incredible, a very rewarding experience for all of us. It's been a turbulent year for the whole planet in the midst of our health crisis, political crisis, cultural crisis. So it's nice to see that science perseveres and we continue marching forward. It was very rewarding.
Something like this connects us all, doesn't it, Nadia? It just brings us all together and it reminds us what's most important in life.
I agree.
Well, now, NASA has an extremely diverse portfolio of Earth science missions. What sets Sentinel-6 apart from all the rest of them?
Sea level measurements that Sentinel-6 provide is our only ocean surface measurements that we can connect to the physics of the whole water column. So not just what happens at the very surface, but what happens from top to bottom. And that's an incredible and very rich data sets that can tell us a wealth of information, what happens with the oceans and how oceans connect with the rest of the Earth system.
Now we have a question coming from social media. So can you take that for us?
Absolutely.
Oh, very good. Shane on Facebook asks, will there be a way for individuals to see the research data that comes from the satellite?
Yes, absolutely. NASA has an open data policy. So when we receive the data from the satellite, NASA science team carefully looks at the data, that everything makes sense, and then makes it available to the public freely and openly.
That's excellent.
That's great, and that's what's awesome is that it's data that everyone can use, from fishermen to meteorologists to so many different people all across the world.
Absolutely, Marina, and that's the foundation of to keep the integrity of science very high, that if you come up with a discovery, anybody in the world can back up and repeat your experiment and confirm your findings or find something that looks different.
And Nadia, what does the mission hope to accomplish in the next 10 years with all this data that is going to come in from Sentinel-A and Sentinel-B? Because it's two spacecrafts that'll launch between 5 years of each other.
By the time we're done with Sentinel-A, Mike Freilich and B, we would have almost 4 decades of sea level data. That's enough to look at the spread of frequencies of how our Earth climate change is happening and how oceans interact with it. We are sort of on a tipping point. What we see that sea level is not only rising but accelerating. When we were launching TOPIX Poseidon back in the day, the rise was about 2 millimeters. Now it's about approaching to 5. So we see that the rise of the seas are getting faster. And just to give you, put it in a context, those millimeters, as my teenage son asked me, why do we care about 3 millimeters? I told him, well, Andre, 3 millimeters per year change in sea level means that we're adding about 300 trillion gallons of water every year into the ocean. And if you line up all those gallons, that would enough to cover distances distance from Sun to Pluto and back. So that's a lot of water that we're coming into the ocean.
Perspective.
Yes.
Nadia Vinogaradova-Schiffer, thank you so much for joining us. It was great to have this conversation with you here, just with the Pacific Ocean behind us.
Thank you, Daryl and Marina.
Thank you, Nadia.
Very good.
Well, time to go back to Kennedy for a very big moment in our launch operations, the unfolding of the satellite solar panels. Joshua?
Before we do that, we want to recap the launch, just a quick moment to share with everybody and let them know exactly what happened about 45 minutes ago. It was a beautiful launch here on the coast of Central California. The Sentinel-6 Michael Freilich satellite, which is sitting on top of the rocket, was ready to go. We had clear skies. There was an ignition of the rocket right at 9:17 p.m. Pacific time. I'm sorry, a.m. Pacific time and 12:17 p.m. Eastern time. And there you see the launch of the Sentinel-6 Michael Freilich satellite going up on the Falcon 9 rocket. And it's a beautiful sight, looking down the barrel, both of the booster as well as the skies above. It just climbed and climbed, racing up to the middle of the blue sky and performed beautifully. No problems with launch. The 9 Merlin D engines belting out their 1.7 million pounds of thrust on their way into space. The rocket just performed perfectly, and there you see a shot from up high and the coast of California. Vandenberg here, of course, a launch site that allows for a certain trajectory that allows Earth science to do a lot of missions here. And then we had the landing, which was really neat. For all of the guests who were here, Michael Freilich's family, watching as that booster touched down just perfectly, nailing the landing. It was quite a sight to behold about 8.5 minutes after launch. The first stage booster now available for reuse. So now we want to check in with Joshua Santora and Philip Hargrove for an update on the second stage.
Well, that's right. We are now going to be having a very big moment as the unfolding of the satellite solar panels moves in. And Joshua, it is an exciting time. Everything's coming into place.
Marina, it really is. Obviously, we work hard to plan for these moments, and we expect that we will succeed, but it's always a relief every time you kind of cross one of those milestones. So we did have the spacecraft separation. We were able to bring you just about live, a few seconds behind reality not too long ago, and now we're waiting on solar array deploy, which in theory should be happening in the next 3.5 minutes. I don't know if we'll have a visual for that. I suspect we're just going to hear a call out that it's been confirmed. So in the meantime, Philip, Launch Services Program, their official task really kind of ends at spacecraft separation. So that's a job well done for that team. I know that they still very much care about the success of the rest of the mission here, and they want to just be there with the team kind of collectively. But is there more responsibility beyond that? I know that there's years ahead of time, but what happens post-flight for a mission?
You're right that in the big scheme of things, our job is pretty much done once the spacecraft separates from the launch vehicle, but there is a lot of post-processing data to make sure that everything went the way that it was supposed to go. So, we recall that, once we lit the candle just a little while ago, the rocket did everything by itself. So we have to take the tracking data that we got from some ground stations and from space-based stations. There's a network called TDRS, or the Tracking and Data Relay Satellite System, TDRS, that allows us to have a really good understanding of where exactly the launch vehicle and spacecraft are at all times. So one of the data products that we get from the launch vehicle is called the OPM, or the Orbital Parameters Message, and that gives us a precise measurement of the orbit state right after separation, so we can confirm that the rocket did its job.
Sure. And on a personal level, because obviously we know that LSP, like all of these organizations and teams, it's made up of people, of individuals, and obviously you guys individually invest, and as a team invest years of your lives on these missions, just kind of putting in that energy. When it flies, when you see it on its way, it's in orbit, it made it where it's supposed to. What's that like personally for you? Is there just kind of a on to the next thing, or is there some sort of like eternal pride that comes with knowing that your work is in space somewhere?
Right. There's definitely a lot of emotions on a day like this. So right now I'm definitely feeling really happy and proud for my coworker who's been working on this mission for a couple of years. He actually sits right next to me in the office. So, I've seen and heard a lot about this mission.
Sure.
And just in general, when it is one that I work on, you just get a lot of perspective on the fact that, I worked on this for a couple of years, but other people have potentially put their whole career, especially for someone like Michael Freilich, who's been so dedicated, or who was so dedicated to this type of work. So it's really an honor to be a part of that, and then it's exciting to look forward to the future and look forward to getting the science data back and see how the actual spacecraft operates.
Awesome. And just kind of spitballing, how many missions do you work at the same time? Because that's one of the other factors, is that no person, I don't think anybody on your team is working one mission exclusively at a time. You're kind of rolling that work. What's that? I know it's a flexible number. What is that like for you guys?
Yeah, rolling is a really good way to describe it. We want to make sure that nobody is, working two missions that are launching like right around the same time. But so a lot of us will maybe have one mission that's a few years in advance, and then one that just launched. So that's definitely the case for me. I have one that launched this year, and then my next mission launches in a couple of years.
Yeah, I think we just got a call for a loss of signal. I believe that's actually for the second stage. That's as we've been hearing those calls for second stage as we travel around the Earth. We're hearing pickups for the new tracking station, ground station, as well as when that loss of signal happens. That's a nominal part of the operation. So no surprises there, nothing unexpected. That's just kind of working rocket science. And tell me about the orbit that we're taking today. I know that we generally end up taking a lot of flights out of Vandenberg for Earth science missions. What's really the cause behind that? Why Vandenberg so much for those?
Right, so really connecting to what Callie was talking about earlier, when you want to do Earth science, you don't want to just look at one portion of the Earth. You often want to look at all of it. You want to get a lot of the surface of Earth. You want to be able to cover that. So if you're able to launch into a polar orbit where you're literally hitting every latitude, you're in a really good place. So Vandenberg, obviously on that Central California coast, allows you to launch with one of those southern azimuths. So we often use Vandenberg for polar launches and sun-synchronous orbits, which are sort of a unique case of that.
Great. Yeah, just a reminder, we are listening in here now. We should be expecting a call out for solar array deploy any moment now. We're just waiting to hear that. Excited for that moment. And as we mentioned, obviously we flew out of Vandenberg today, right on time, 9/17/08 Pacific time. That's 12/17/08 Eastern time, and we are awaiting that solar array deploy. Post-solar array deploy, really that last milestone, there's kind of a larger gap as we travel around the Earth. I don't know if we can pull up that STK, that animation again, to kind of check and see where we're at. I'm not sure what its status is. So this actually is going to demonstrate a little bit about where we are, not exactly the location of the spacecraft. I think that's tracking specifically second stage right now. So we are definitely in a little bit of a holding pattern here, hoping to hear that call out for solar array deploy, which we wouldn't hear that call until it's complete. So we wouldn't necessarily, it could have begun already, and we just are waiting for that call that it's been completed, depending upon the complexity and timeline for that, as well as any kind of communication that's necessary.
Right, and it's definitely, important to note that there are a lot of complicated things that need to happen right at this moment. The spacecraft just, got into space, so it has to, it has to fit into that payload fairing. So there's often times where you need to deploy a big boom, deploy your solar arrays. We'll be deploying antennas, so it's able to communicate with the ground. So all those things are going to be happening, in this near-term period.
Awesome, very good. Can you talk any more about the tracking system? I know you kind of spoke about that a little bit, but with TDRS, we have kind of an on-orbit system. We've heard these call-outs for these ground station tracking systems. What's the thought process there?
Right.
How does that? I guess not thought process, but how does that work?
Right. So, like I said, there's ground stations. I believe on this trajectory, we received telemetry on its way. There was a station that's in South America, one that's in Southern Africa, and things that are allowing us to really know what's going on, because you don't want to just let it go and then just wait until the very end. You want to be tracking as you go. So we're receiving that data really in real time. And when it comes to TDRS, that is a geosynchronous satellite system. And the idea there is to have satellites that are basically parked above a particular location on Earth at all times. And the way that works is that the orbit period, the time it takes the spacecraft to travel around the Earth, is the exact same amount of time that it takes the Earth to spin around its own axis. So that means that you can park something right above the U.S. or whatever other longitude you want, and when you are launching things from the surface of the Earth, you can know, it's going to pass over TDRS East. They're numbered in a certain way, and you can easily plan out your communications.
Very good. Thanks for that, Philip. We're going to actually move along here. We're listening in. Nothing to be alarmed about. As Philip mentioned, there's a lot of things at play here, and it's not uncommon to have these kinds of calls delayed. We may even not hear that officially confirmed until we get back to that Alaska tracking station. So we're going to run back out to Daryl. I know Daryl has some more for us on this mission.
All right. Thank you very much, Joshua. And while we await...
Okay, guys, I think a problem, I don't see a problem. Maybe there could be a problem with the solar array deployment. But if we get the signal from the another tracking station, I think that's what they're waiting for. Let's hope everything is good. And yeah.
Mechanical or electrical trigger for this.
No, usually it's just a little bit of paraffin holding them in wax. And you wait for it to be in the proper attitude to get the sun and have it melt at a certain temperature, and the solar rays will spring out and be in their position.
Then the solar rays just pop right out.
There's other mechanisms at times where you do an electrical deployment, but this is very simple. The simpler you keep it, the better.
Oh, wow.
Simple to study the ocean.
Just
so
a
like
paraffin wax.
Yes. The launch, from our perspective, viewing it just looked magnificent from out here. And Omar can't help but notice the booster's back there too.
It's a nice sight to come over the hill and see the booster sitting there without the second stage and the payload fairing. And what a sight. This is very unusual for being...
Actually, since it's a this paraffin wax, so I can totally understand there could be a delay. Maybe it is not facing the sun properly or something like that, and that's why the paraffin wax has not melted yet. But since it's a case of melting only, no worries. Any times in some orbit or so, it will obviously come in that position where it can melt easily, and then the panels will deploy, hopefully.
For this mission, and he's back there working it, so we appreciate you popping out. And then of course, you talk about the clear sky. As we were looking at it, we could see the separation of the first stage from the second stage. I mean, it seemed like for like 3 or 4 minutes, it was amazing just how clear the sky was.
Crystal clear blue skies. And like you said, I've had a dozen launches here before, and it's just that marine layer gets sucked into this valley here, and usually we can't see a thing. I remember InSight very well. We heard it, but we didn't see it. Now, the last launch here was ISAT-2 from Vandenberg in 2018. So how does it feel to be back to launch another Earth science mission today?
So ISAT was Launch Services Program's last NASA mission out of here, another of Dr. Freilich's missions, and that was on the last mission of the Delta II vehicle. It's great to be out here. Those long periods of time, even for SpaceX, their pad's been down for roughly almost a year and a half from their last launch there. So to get the tempo going again, we've got missions coming up next year out of here, starting with DART, which is the double asteroid redirect test. That is going to be so cool, because this is one where we're going to be catching up to the asteroid Didymos and going after one of its moonlets that's about 160 meters across. We're going to impact that moonlet and try to impart energy to redirect it. So pretty cool planetary defense type mission, and that'll be coming out of here in July on a Falcon 9 rocket.
Yeah, and then of course 5 years from now we'll have another Sentinel-6 B. We'll then go up to follow on with this mission.
That's right, and shortly after this summer, in the fall, September 16th, we've scheduled Landsat for out of here. So that continues with our partners at the Geological Survey, the mapping of the land surfaces and water surfaces for almost 50 years now. So it's a continuous measurement of real scientific data that is available to all to look at and to analyze and to speak the truth.
Earth science missions, so exciting over the next couple of years. Then after Landsat, we've got NISAR and SWAT launching as well. So it's going to be great for Earth science.
That's right.
Omar Baez, Launch Services Program Launch Manager. Appreciate you coming out here and joining us. Congratulations.
Thank you.
And obviously that NASA will be in collaboration with ISRO, so yeah, that mission will also be very cool to watch.
Solar panels and the acquisition of signal, and that's actually going to tell us that the satellite is very healthy and it's in the right orbit, and we're expecting that hopefully here, Daryl, give or take about 15-20 minutes. Yep.
And so in the meantime, we are going to pause our broadcast and come back with an update about the AOS. But before we do, we want to pay one last tribute to Michael Freilich and his tireless determination to better understand our rising sea levels.
In the science, he had high standards for himself and everyone around him.
Earth system science is bigger than any particular agency. It's bigger than any single nation. It's bigger than any single continent. And I surely hope, because humanity requires it, that we make some significant progress in understanding.
You did good, Dr. Freilich, for all of us. And for that, we're all very grateful.
Ignition. Liftoff of the Falcon 9. Godspeed, Sentinel-6, in memory of Michael Freilich.
Okay, so well, so guys, we just saw the liftoff and everything, the second stage ignition and everything, basically the deployment. But the only thing left right now is the solar panel deployment, news about the solar panel deployment, as well as the acquisition of signal. So when that acquisition of signal will happen, so we will be basically see this our broadcast will continue upon expected acquisition of spacecraft signal. So once we have a signal acquisition, so then only we will be able to have the basically those orientation of the spacecraft, how it is behaving, in what position it is, and whether its deployment has been taken place or not. But I'm really hopeful that deployment is not a big thing they need to worry about, just because it's not a mechanical or electrical thing which could fail in orbit. It's just a paraffin wax which is holding those solar panels in place, and I'm really amazed to see that this only paraffin wax is holding those solar panels in just one position, and we need just only the satellite to be in a perfect, or you can say in that particular orientation to face that sun, and once it faces the sun, the paraffin wax will melt, and then we can basically have the arrays deployed. So that's what the science is, and simply I should literally say that they glued the solar panels to the position and waited for now they are waiting for that glue to melt. Actually that only they did. So it's quite acceptable and quite expected also for this thing to misbehave in certain way, because there is no trigger or something like that in this deployment mechanism, right? They don't have to have that any mechanical thing to deploy or any electrical switch to trigger so as to have those motors running. Nothing like that, just wax and sun, that's all we need. Yeah, the perfect orientation is the key, and hopefully those arrays will deploy and we can have this satellite perfectly orbiting and working in the space. But I don't know whether it will be able to work without the arrays deployed. I mean, the only thing, if it wouldn't be able to work with the arrays deployed, will be because of the generation of energy, the required energy basically, because it has the solar panels exposed only, so whenever the sun hits that area, it will generate electricity. And obviously those two solar panels which are just above that deployed one, those are fixed, and they are already in that position. So I mean, if any cause, the only thing which they can do if the arrays are not deployed is wait for that, because they will be having enough power to just keep this running from those solar panels, if I'm not wrong, and hopefully I am not, because those solar panels will obviously be generating some electrical energy. So those above one are hopeful, and will keep the spacecraft aligned. Hopefully then the scientists could figure out how to orient the spacecraft so as to have that paraffin wax reach its melting point and arrays deployed. Yeah, that's the thing. I think so. And guys, I really liked this satellite and those instruments which is having, and the one which is GNSS-R or radio occultation is my favorite one, because it will literally be acquiring signal from the GPS satellites which is in space, and the constellation is in space, and it will be able to have the you can see the composition of the atmospheric layers, the troposphere, stratosphere, ionosphere, and everything like that, because when the signal reaches atmosphere, it bends because of refraction. That's the phenomena, refraction. So acquiring the position of the GPS satellite along with the signal acquisition as well as with this Sentinel-6 satellite position, we can actually figure out how much that radio signal bent, and that bending of that radio signal could tell us what is the refractive index of the atmospheric layer, if I'm not wrong. Yeah, that will obviously tell the refractive index of the atmospheric layer, and from that refractive index hopefully we can like figure out or basically assume or predict what could be the composition to have that thing refracting this much. Maybe if it is refracting more, that means something is there not blocking, basically refracting that satellite signal a little bit more, which means what could be the, basically they have a chart, right? The refractive index versus the materials. So if they have a refractive index of 1.5, which they can't, obviously that would be too much, but if they have that, that will be matched to something like sulfur or this any other pollutants or something like that. So they can just figure out what is the composition of the atmosphere, and yeah, better predict the weather. So that is the thing which I'm really looking forward to, and hopefully let's have this confirmation. I don't know how much, for how long I'll be able to talk, but yeah. And the other thing, that instrument also, which measures the sea level with the utmost accuracy, that also is a very cool thing to visualize. Basically it is not just bouncing off the signal from the satellite, means the sea, basically sea or ocean, because when the signal reaches the atmosphere also bends the signal, okay, and also the position of the satellite will not be the same. It will just the speed of the satellite is 4.5 miles per second. That's what they mentioned, right? So if for let's assume that the signal takes just a second also to reach back, go to the sea and hit and then reach back, then also the satellite would have traveled 4.5 miles. So at that time it won't be there, right? So the satellite basically has to have that signal launched or beamed at an angle, so that after reflecting from the surface of the ocean or sea, it creates such an angle that it reaches back to the satellite only at 4.5 miles or something like that. They know what is the speed of the satellite and how much could be their you can say the distance, because obviously they somewhat they know what is the distance, and obviously we must be having some margin to don't pinpoint actually the beam, but yeah, that's the thing. Basically, I just wanted to say they must be beaming that signal at an angle so that it reaches, it hits the surface at an angle and reaches the satellites properly. That's what I meant to say. And yeah, the AMR, this instrument is also very unique, but I don't know what to say about it, because I really don't know. But I can already talk about something like they said, the DART mission, which is going to launch in July from this launch pad only. And speaking about this launch pad, basically, you just saw the Falcon 9 launch. Obviously the SpaceX launches are too good to handle and these was one of them, no exception. And this launch basically had I mean to say, obviously the launch happened, then the spacecraft, the MECO happened, the stage separation happened, and then the boost back burn. So did you just see that we actually saw that thing, the interstage kind of burning in fire, just because of the flip maneuver, because it actually performed the flip maneuver just a second, or you can say just after it was separated from, and the engines were ignited. So that the engine, if I'm not wrong, the engine plume is also pushing the this Falcon 9 first stage to rotate and kinda go retrograde. So it will be helping it to rotate, and yeah, that's the thing. And that's why I noticed that fire in interstage. And on all those launches which has been done with the boost back burn, I have noticed that. So it's completely nominal, as they say, to see that. And obviously then the boost back burn. Okay, so okay.
Welcome back to Vandenberg Air Force Base in Central California. My name is Daryl Nail. I'm joined with Marina Jurica from JPL. Thanks for joining us. We have an update for you, some good news. We managed to get an acquisition of signal from the Sentinel-6 Michael Freilich satellite, and as well as confirm the deployment of the solar array.
That's right. So the solar arrays, the solar panels have now been deployed, and what's incredible is we got the signal of acquisition. In layman's terms, it basically just means that the satellite is healthy, it's in the right orbit that it's supposed to be in, and we are ready to rock and roll to get that science getting to us as soon as possible.
And that's an exciting moment for us here at NASA, as well as ESA and our European partners. It all started at 9:17 in the morning Pacific time from right here at the Vandenberg Air Force Base Launch Complex 4. SpaceX launched their Falcon 9 rocket from that launch complex around 12:17 p.m. Eastern time, and it was an incredibly beautiful launch. Rare conditions here for a launch. A lot of the folks around here say we had clear skies, beautiful as this rocket lifted the satellite off the launch pad, Marina.
Oh, it was incredible. It was crystal clear, and usually we have fog all across this area, a really thick marine layer, but it was crystal clear blue skies. And then we saw the booster land back next to us. That was just unbelievable. We heard that sonic boom. It was so powerful.
And in fact, it came down right in eye level, right back at the place where it launched off the pad. And so it was just fascinating and a wonderful thing to watch. But the mission then later continued. And you can see there the separation of the satellite from the second stage booster. That confirmed. Beautiful video there from an onboard camera on board SpaceX's second stage, watching that Sentinel-6 Michael Freilich satellite go off into space, and Michael Freilich's family here to enjoy it. We want to toss it now back to the Kennedy Space Center, where Joshua Santora and Philip Hargrove are there and documented and heard the acquisition of signal. Gentlemen.
Yeah, thanks, Daryl. Obviously, all smiles here. That's what we want to hear. We got a great set of calls there, and we heard a number of times calls come out repeatedly saying, hey, we can confirm we definitely got the solar array deploy, which was something I know that we had left you last time not sure of, so glad that happened.
Right, and it was really great to hear the excitement from the spacecraft team over the nets, so they're happy that they can talk to their satellite, and yeah, Sentinel-6 Michael Freilich is on its way.
Yeah, it's funny, typically during a launch countdown and even post-liftoff, it's very quiet in control rooms. It's very focused. You want to make sure everybody can hear what they need to hear, but we heard calls coming in and just people just explosively cheering in the background. So excited for those teams. A huge congratulations to all the teams involved today. Obviously, ESA, JPL, LSP, the Space Force, and SpaceX. So, Philip, it has been a pleasure to have you alongside me. Appreciate your insight and expertise on the topic of rocketry.
Thank you so much. This was an awesome experience, so I'm glad I got to share it with you.
Fantastic. And from here at the Kennedy Space Center, doing commentary, there's a lot of missions between now and then, but we hope you'll be back in about 5 years when we get to see the sister of Sentinel-6 Michael Freilich fly, Sentinel-6 B, the twin sister that will fly in 5 years to continue that service of ocean observation. That's going to do it for us. Daryl, Marina, back to you.
All right, Joshua and Philip, great job, guys. We appreciate it. And like you said, in 5 years, we'll have that second satellite. That really helps to that continuity of data. Right?
That's right, the consistency and the continuity, adding that full 10-year block. And that's what makes it unusual to other Earth science missions, is that the satellite is already built and it's stored and it's ready to rock. And in 5 years, we'll get that one up and it'll be 10 years, a full decade of this critical information, because we know sea level rise is happening. We know it's accelerating, and this is just going to give us another 10 years, which will be 40 years of consistency and continuity in this data.
And what a place to watch all of this, right? We had beautiful weather. We're here on the central coast of California. Many thanks to the 30th Space Wing for helping us out and making this possible. They really did a great job. It was so beautiful. I've been here so many times. This whole valley is usually covered in fog. We were here just a couple of days ago and everything was foggy because we get this marine layer that just pushes right into the valley. But today, everyone was in place. The weather was in place for us, the rocket was in place, the booster was in place, and now the science is in place. That's wonderful. And how'd you like that landing? Oh, that was incredible. I've only seen it one other time, and that was the double landing, which was pretty amazing. But this was just as amazing in my home state, in my hometown, with my family watching, and most importantly, Michael Freilich's family watching. What a moving moment when we got to speak to his children. He was an incredible, incredible advocate for Earth science missions, and especially for altimetry data and sea level rise. And it was so heartwarming to see them here. Yeah. It was just wonderful. There's another star in the sky. Yes. It's got Michael Freilich's name on it. You've got it, Daryl. All right. Well, we thank you for joining us. That's our coverage of Sentinel-6 Michael Freilich, the launch of that satellite on a Falcon 9 rocket by SpaceX. We appreciate you being here. For everyone here at NASA, thank you for watching, and remember to keep looking up.
Okay, so that was a pretty good thing to know, that solar arrays have been deployed successfully and everything was in place. Oh yeah, this Artemis mission is itself a very good thing to talk about, but I won't be talking about this mission right now, so I think we should okay. So guys, thank you so much for tuning in. We had a beautiful liftoff, the successful spacecraft deployment, as well as the solar array deployment. Although we had some hitch and glitch here and there, but it's okay. That's cool to cool to have. That's what builds excitement, right? So but in the end, the ending was happy, and yeah, that's what we want. So thank you so much for tuning in, and hopefully in just a couple of days we have this Starlink mission of the SpaceX. So do join in for that. I'll be streaming that. So yeah. So until then, this is Priyanshu Royala signing off. You just saw Rocket Gyan. Stay safe, stay healthy, and bye bye.